You ready? You ready? You ready? You ready? You ready? So today, we're trying to solve quadratics with complex solutions. Oh no! What are you gonna do? How about, let's go and take a look at this, but maybe we do need an introductory example, so here we go. So, on something like that, teach me how to factor. I tried. What? You could try to factor that, but it's not real, like your friends. So you could use complex factorization, or you can go and use the square root property. Here we go. If we had a game plan, we would isolate that root. Root? What root? Well, it's about to be a root. Over here on the left side, I'm left with an x squared, and on the right, that's a minus 16. Oh, boy! And now what? Oh, no! Third camera, ready? Here we go. So now I want to take the square root of both sides, but I'm not going to forget the plus or minus square root minus 16. That's gonna be. Whenever I take the square root of both sides, I use the definition of absolute value, and that's where the plus and minus square root 16 minus 16 comes from. So that's plus and minus the square root of 16 times a minus 1. Fun. And the root of the product is the product of the root, so that's plus and minus the square root of 16i. Why? It's because the square root of minus 1 is I. So then it goes there, and then it goes there, and then I see right there that x is gonna be plus and minus the square root of 4. I'm not even wearing my glasses. Would you call me? Now I'm on up over here, see? Oh, hey, now, what do we have to do? We have to back that math up. Why? Because when we have these equations, we got to get them set equal to 0. Why over there? Because then, that was the square root property. It's kind of different, but it's kind of the same. Anyways, I have quadratics, so I'm going to try to back that math up. I'm going to add that 18 to both sides. Add that 18 to both sides. Okay. Is that 18? I think it was supposed to be 81. Anyways, we'll play it with the ball lay. Whoa. Yeah, look at that. It was supposed to be 81. Aw, dag. Anyways, well, here we are. As you can tell, I don't do these ahead of time. That's an x squared plus an 8. Great. Wait, x plus 6 and 8, that's a 4, sure. And carry a 1. It's okay, it's not heavy. So 1 and 1, that's a 34. If you're out there, can you check and make sure that that's 34? Sure. Now, you're looking for the factors of 34. That had to be 8. Great. Wait, I don't think that there are any. No. So, you go. Well, I guess you could break it down. That's 34. That's 1 and 34. That's 2 and... Ooh. Is that 17? 17, 7 plus 7 is... 4 carry. Yeah, okay, so none of those had to be 8. Great. Wait, so now what do I have to do? X is equal to minus b. Is that all quadratic? Plus and minus square root. No, that x doesn't go in there. Why? Because when I'm using the quadratic formula, I'm only using the coefficients. When it's an ax squared plus bx plus c, we read off our a's, our b's, and our c's. So x is equal to minus b plus and minus square root b squared minus 4ac all over 2. Again, this is the first time we're ever shooting live, so, that's gonna be a minus 8, great, plus or minus the square root of, okay, Google, what's 4 times 34?
The answer is 136.
136 negative, because that was positive, sure. And then, okay, Google, what's 136 minus 64?
The answer is 72.
72. Oh, it's gonna work out all nice. This mistake happened for a reason. Okay, plus and minus, what'd she say? 72 minus 72 all over deuces. But what's 72? Oh, 72 is there? What's 72 divided by 9? Okay, Google. What's 72 divided by 9?
The answer is 8.
Oh, great. Wait, then that's got a 2 and a 4, sure. There are squares in there, so the 4, because I got 2 2s, I get 1 out. The 9, because I got 3 3s, I get 1 out. So then I got out, I guess on down here. Whoa, that's a minus 8. Great. Wait, this is plus and minus now. A 2 comes out because there's a pair, and a 3 comes out because there's a pair, and a 2 times 3 is why that 6 got out there. So then, right here, whoa, what's left over? Oh, you don't have any friends, do? But then what can I do? I can go and I can split that fraction. That's too low in that action, so we'll come over here. Oh, new guy, you're over here. That's all over a deuce. I split those two, and that's a minus 8 divided by a deuce, plus and minus the square root of 6 root 2 divided by a deuce. Oh, then I deduce I can reduce by a deuce. Ah, which one am I even? Oh, hi over there. Okay, down over here. That's minus 4 plus and minus 3 root 2. Ooh. Wait, wasn't that supposed to be imaginary? Because that was a minus. That should be a minus. That should be a minus. And then I. Donut. That one's so new.